So hello everyone. So now in the second lecture, we talk about resistance, inductance, and capacitance and their behavior with the alternating current waveform. Now see, this is the L, this is the capacitor, and this is the resistance. Resistance is a heat dissipating device. It means it is not store any energy. It dissipates its energy in the form of heat, whereas inductor and capacitor stores the energy. Inductor store its energy in the form of current in the magnetic field, and it is represented by the energy across it is half Li square is the energy. And in capacitor is also a storing device which also stores the energy half CV square in the electrostatic field. So both inductor and capacitors are energy storing device. They are not consuming any power, whereas resistor is not storing any energy. It dissipates the energy. Now we have to see the behavior of resistance, inductance, and capacitance when they are supplied with the AC individually as well as in combination with resistance, inductance, and capacitance. The behavior of capacitor on low frequency is act as a open circuit, and I hope that every student know that this is the DC having frequency is equal to 0. DC waveform is have the frequency equal to 0, whereas in AC waveform the frequency is present, okay, or it is not equal to 0. So when you have a signal which has a low frequency, in that case capacitor act as an open circuit, whereas if it has the high frequency, then it acts as a short circuit. Whereas for the inductor in low frequency, it acts as a short circuit, and in the high frequency, it acts as a open circuit. So this is the basic behavior of the capacitor and inductor during with the change in the frequency. Now come to the AC. When you give the AC to a pure resistive circuit. See, in our last lecture, we know that this is the AC voltage and its representation. V is equal to Vm sine omega t. Omega is the angular speed, t is the time, Vm is the maximum value. So see, and this V is instantaneous value. So see, here it is already mentioned. As per the diagram, the current flow in the circuit is IT, and see the voltage across the resistance is, we assume here, VR. So VR is the voltage across the resistance. Okay, so the equation 1 itself is a V is equal to Vm sine omega t. So instantaneous current is V by R. Now it is also write like this, Vm sine omega t divided by R. So current is having the equation as Im sine omega t, and where Im is equal to Vm by R. So see that the equation of voltage V equal to Vm sine theta or omega t. Theta is nothing but omega t. So V is equal to Vm sine omega t. See, both is having the equation Vm sin omega t and I is having Im sin omega t. So if we draw the waveform, see, this is the waveform. Green one is for the voltage and red one is for the current. Why the magnitude of current is low? Because it is divided by R. Okay. That's why the magnitude of current is little bit low as per the value of register. So this is the representation of waveform for voltage and current in case of resistance. We observe from this waveform is that the waveform both are in the same phase. Same phase. So there is no phase difference in case of resistance. See, this is the current IR and this is the VR. This is the vector representation or phasor representation, and VR is having again the larger magnitude than the IR. The phase difference in voltage and current is 0, whereas the impedance or the total load is only consisting by R. So the phi is 0, then cos phi is equal to 1. The power factor. Power factor is new term which we will discuss later also. But power factor is nothing but it is the angle between voltage and current. If you have any angle in between voltage and current, it is nothing but this is the phi. Okay. So in case of resistance, both voltage and current is in same phase. So there is no phase difference in between voltage and current. That's why they are in the same phase. And so power factor is 1. Now, instantaneous power. Instantaneous power means it is the multiplication of instantaneous voltage multiplied by instantaneous current. And we know that the value of instantaneous voltage is Vm sin omega t multiplied by Im sin omega t. So it makes the equation is Vm Im sin square omega t. Okay. Now replace sin square omega t is equal to 1 minus cos 2 omega t divided by 2. When you replace this by this sin square omega t, we will get this equation Vm Im by 2 minus Vm Im by 2 cos 2 omega t. So this is our instantaneous power across the resistance. Now the power has two components. First component is Vm Im by 2, and second component is Vm Im cos 2 omega t by 2. First component is a constant. Vm, value of Vm multiplied by Im and divided by 2. Whereas the second component is having fluctuating part because of this cos 2 omega t. And see the 2 pi f. Omega is equal to 2 pi f. Now it is multiplied with the 2. So what happened? It is rotate with the double of the frequency of the voltage and current. Suppose this is the voltage and this is the current. Okay, now the frequency of this particular portion is twice of the base signal. So what happened? The power is only this portion of power is having double of frequency. It means it has a shape like this. So this portion and this portion for this particular half is cancelled by each other. That's why we put always this part or second part is equal to 0. So the whole power is only P is equal to Vm Im by 2, and we know that Vrms is Vm by root 2 and Irms is Im by root 2. So we have this component Vm Im by 2. So you can represent Vm by root 2 multiplied by Im by root 2. So we also write like this. Okay. So this is our actual power across the resistance. Now again, this is the derivation for the average power. You can also find by this 0 to 2 pi Vm Im I minus cos 2 pi 2 omega t by 2. The same thing is again, and at last what you will have P average is V multiplied by I when you solve this particular equation. Now the basic is the graph. See, this is the voltage, this is the current. Now power, instantaneous power is equal to V multiplied by I. So this is the positive power. So see, this is the positive power. Our main power is, average power is V into I. And in case after that, this 0 power is equal to minus V into minus I. But due to both the sign is having negative for voltage and current, its power make it positive. So in case of negative cycle, both for current and voltage, power is still positive. See, in both cases, power is positive. Clear? So anytime in the resistance, power is always positive. Okay. Now one numerical. An AC circuit consists of pure resistance 10 ohm and is connected across an AC supply of 230 volt 50 hertz. Calculate number 1 current, power consumed, power factor, and write down the equation for voltage and current. So what is the basic circuit is? Pure resistance of 10 ohm. So this is the 10 ohm and connected across 230 volt. Frequency is 50 hertz. This is the given circuit, 230 volt AC. Now you have to find current, power consumed, power factor, and its equation for voltage and current. Now first given is R. R is equal to 10 ohm. So this is R equal to 10 ohm, voltage is equal to 230 and frequency is equal to 50 hertz. Now current is what? I. All the given values in the numerical is RMS value. Okay. So from here we find the RMS value of current. I is equal to V by R. So 230 divided by resistance 10 is equal to 23 ampere. Now power consumed. Power consumed is what? V RMS multiplied by IRMS is equal to 230 multiplied by 23. So the total power consumption is 5290 watt. Now power factor. In case of pure resistance, what happened? In case of pure resistance, voltage and current is having same phase. When both are in the same phase, there is no angle in between voltage and current. So phi is equal to 0. So in that case, power factor is equal to 1. So this is the answer. Now voltage and current equation. For voltage equation, we know that there are two types of voltage equation for instantaneous: Vm sin omega t and I is equal to Im sin omega t. So we need this Vm. So Vm is what? Root 2 Vrms, and Im is what? Root 2 IRMS. Okay, and we have the value of Vrms. So what is the value of Vrms? Vrms is 230 volt. So here you write simply root 2 multiplied by 230. It gives you 325.27. Whereas Im is equal to root 2 multiplied by IRMS. So root 2 multiplied by I is 23. So 23 is equal to 32.53 ampere. So this is Vm and this is Im. Now for this equation, we have to find omega. Omega is what? Omega is 2 pi f. So omega is equal to 2 pi f. So 2 pi multiplied by 50 will give you a 3146 radian per second. Okay, so this is your value of omega. Now write the voltage and current equation. Vm is 325.27 multiplied by sine omega t. So sine 314.16 t. I is equal to Im sine omega t is equal to 32.53 sine 314.16 t. So this is the two equation for the resistance. Now we complete this part for the resistance. Now here we discuss complex number, because before going for inductor L and capacitive circuit, we have to know about some complex imaginary number. Everyone know in mathematics is that there is a complex imaginary number I. But in electrical engineering, to avoid the confusion, because I is itself is represented for instantaneous value. So here we use J. Okay, in place of I, we use J. So J is nothing but it is equal to under root of minus. If you square it, then equal to only -1. If you cube it, then it is minus J. If it is J to the power 4, then it is +1. And if it is J5, then it is again J. It means again -1. Now we have in this when you deal with the inductor and capacitor, we have one term impedance in our numerical. So before the understanding the impedance portion, you have to understand the what is complex number and what is complex conjugate. Suppose if A and B, two numbers are real numbers, then it is represented like this, okay, in rectangular form. And for the same, the complex conjugate is in place of plus, it should be a minus. So A minus Bj is the complex conjugate of Z. So you have to remember these 2 points. If you want to find out the magnitude or the mode, so by this you take the mode and you see in this way you find the magnitude. Okay, so this is the main formula you have to use when you have to find the magnitude of Z. Now the angle in between these two quantity is represented by B by A. Tan theta is equal to B by A. And if you take the inverse of tan, then it is the theta is equal to tan inverse within bracket B by A. We also represent this Z in terms of exponential. Okay, but in the BEE, it is not necessary to use in the form of exponential. We use generally this method and this method. Okay, because at higher level, it is very useful in the form of exponential. So see, we also see that what happened when we use the exponential term. So this is the Z and its representation. And you also represent in the form of exponential like this, mod of Z multiplied by e raised to power j theta. If theta is pi by 2, then your e raised to power j pi by 2 is equal to j. If theta is equal to pi, then is e j pi is equal to -1. If theta is equal to 3 pi by 2, then e j 3 pi by 2 is minus j, and e raised to power 2 pi or equal to e0 is equal to +1. Now come to the basic power. When AC circuit is having pure L, it means there is no resistance in this, only pure L, or the ideal condition for the inductor. So in that case, what happened? In that case, whenever you apply the AC waveform Vm sine omega t to a purely inductive coil, then what happened? A back EMF is produced. A back EMF is produced due to Lenz's law. Due to Lenz's law, or due to the self-inductance. There is a self-inductance in the coil which is opposite of the supplied voltage. So see here, this is the self-inductance of the coil. EB is equal to minus L di by dt. Now this E is just opposite to the supply voltage as per the Lenz's law. Okay. Now, if there is no ohmic drop, the applied voltage has to overcome this self-induced EMF only when this is Vt is equal to L di by dt. Okay. So this is our basic equation. Clear? Now, here Vt is what? Vm sine omega t as mentioned here. Now, Vt is equal to Vm sine omega t. Now put here, this value you put here and equate it with the L di by dt. So Vm sine omega t is equal to L di by dt. So di is equal to Vm. This L is coming over here, Vm by L sine omega t into dt. So this is the equation. Now you integrate to find the value of I. So this is the equation. Integrate sine omega t dt. So see this is the equation. I is equal to Vm by L integration of sine omega t dt. Now what happened after the integration? What you will get? Vm omega L cos omega t. Now what happened? In place of that cos, we can write sine omega t minus 90. In terms of sine, instead of cos, we write the equation in terms of sine and take the angle which is subtracted from the omega t, that is of 90. Okay, so by the formula, we can write our I is equal to this equation. So here one thing you noted that Vt is equal to Vm sin omega t, whereas It is equal to Vm omega L sin omega t minus pi by 2 or 90. Clear? So this is our equation of voltage and this is our equation of current. Now what is the value of Im here? Im is nothing but Vm divided by omega L. This is the value of Im. So you also write this equation. I is equal to Im sin omega t minus 90. So what this equation represent? V is equal to Vm sin omega t. I is equal to Vm by XL. Now from where this XL is coming? First of all, we have to talk about this. So omega L is nothing but represented as XL. Omega is what? 2 pi f L is equal to XL. So it is inductive reactance. It is what? Inductive reactance, and it is in the ohm. You have to remember this. The unit of inductive reactance is in ohm, whereas the unit of inductor L is in Henry. And unit of this XL is ohm. So this is the basic formula. XL omega L is equal to XL. Now we can write in place of omega L is XL. So the equation for current is Vm by XL multiplied by sin omega t minus 90. So this is the equation for current. Now we draw this two. So take a reference V. See, this is the V. It is starting from the 0. There is no phase difference or phase shift. So we starting for the drawing the waveform for sine here. See, this is the representation of voltage Vm sin omega t. Now the current is having lag of 90 degree. So current start after the 90 degree. See, this is 90 degree phase shift. So see, current is starting from here. So this is the waveform of current when only inductor is present or the pure inductor is present in the circuit. Okay. And if you see here, the vector representation or the phasor representation of the inductor, take the V as a reference and 90 degrees just lag behind by 90 degree. Okay, current is just lag behind by the 90 degree. So this is the phasor representation and their rotating speed is represented by omega. Now see here the impedance. Here the term, the impedance is equal to XL. Phase difference in voltage and current is now 90 degree. And the power factor in this case, cos phi is the 90. So phi is here 90. So cos phi is equal to 0. So the power factor is in the case of inductor is 0. Now power. Instantaneous power across the inductor. So this is V multiplied by I. You know that V is represented by Vm sin omega t multiplied by I is Im sin omega t minus pi by 2. So after multiplication, what we will get? So see here, Vm sin omega t and Im sin omega t minus 90. So Vm and here Im, we can write in place of sin omega t minus 90, we write minus of cos omega t. Okay. So see, after writing this, what you will get? You have one formula, sine multiplied by cos 2 sine theta multiplied by cos theta is equal to sine 2 theta. So by using this formula, you replace this sine omega t cos omega t multiplied by 2. Okay. So you will get the formula of PT. One second. PT is equal to Vm Im by 2. So you have the power, instantaneous power of Vm In by 2. Okay. But here one more component is sine 2 omega t is multiplied. So this is the total power, instantaneous power across the inductor. Okay. So see, now why this power is equal to 0? I already mentioned in case of resistance is that, now see 2 omega t. What do you mean by 2 omega t? It has a double frequency. It has a double frequency of voltage and current. See, this is the voltage. It is start from here and it is pi. It is 0 at pi and again increasing in the negative direction and stopped here. See, this is the waveform of current again. Now what happened? How you can calculate power? Power is equal to V into I. Suppose V is here positive and I is negative. So V multiplied by minus I is equal to minus P. You see, power is negative till this point. Jab tak current, till the current is negative. From this instant, current is positive and voltage is also positive. So V multiplied by I is it gives the positive power. So see, the power is having the waveform like this. Okay. Now again, after this point, what happened? This is the voltage and this is the current. Now voltage is negative and current is positive, give the negative power. So again, your power is negative till this point. At this point, what happened? Your voltage is negative and current is negative. So voltage is negative and current is negative. So power is positive. So see here that negative power, positive power, negative power, positive power, negative power, and positive power. So in this fashion, your power is having double the frequency of the voltage and current. So see, this positive and this negative, this positive and this negative will cancel each other. And the instantaneous power across the inductor is equal to 0 because of this double frequency. Clear? Now you also calculate the average power. You have the formula 0 to 2 pi Vm Im sine 2 omega t divided by 2. This is the area for the power divided by 2 pi. And when you integrate this, first of all, you take out this Vm Im 4 pi. Okay. Now you replace this sine 2 omega t after the integration. Integration is minus cos 2 omega t by 2. And 0 to 2 pi is the limits. After that, what happened? Vm, Im, 2 is multiplied by this 4 pi, this 8 pi multiplied by, after putting the limits 0 and 2 pi, we will get cos 4 pi minus cos 0. Then what you will get? Cos 4 pi is 0 and cos 0 0. So that means your power is 0. Okay. So your average power consumed by the pure inductor is always 0. So what you have seen from the L when it is supplied by alternating current, you see this is the basic formula for Im is equal to Vm by omega L. Omega L is also equal to XL, is known as inductive reactance. Okay. Vm is the maximum voltage and inductive reactance XL of the coil, and it's given in ohm. The unit of this is in ohm and the unit of L is in Henry. Unit of omega is radian per second. Okay, whereas XL is also equal to 2 pi FL or omega L. Here. So when you see the formula for XL is equal to 2 pi FL, it means that it is directly depend on frequency. So XL is directly proportional to the frequency. Okay. If frequency is greater, then XL is also increase. If frequency is lower, then XL is decrease because it has the direct relationship. Now, this is the numerical. An inductive coil having negligible resistance and 0.1 Henry inductance is connected across a 200 volt 50 Hz supply. Find inductive reactance, RMS value of current, power, power factor, equation for voltage and current. So our basic circuit is like this. Negligible resistance means in question they are talking about only inductance. So 0.1 Henry. And the supply voltage is 200 volt 50 Hertz. So this is our basic circuit is given. So L is equal to 0.1, V is equal to 200 and F is equal to 50 Hertz. Inductive reactance, the formula for inductive reactance, first we have to find inductive reactance means XL. XL is nothing but omega L. Omega L is 2 pi FL. So 2 we know 2 pi multiplied by frequency 50 into value of L is 0.1. So the equation gives XL is 31.42 ohm. Now RMS value of current. So for RMS value, RMS voltage is given 200. So 200 divided by XL. XL is 31.42 ohm. So this is 6.37 ampere. Now power is VI cos phi. Now power is VI cos phi. But in this case, we know that in case of pure inductance, phi is equal to 90 degree. For phi equal to 90 degree, cos phi equal to 0. So the power consumed is equal to 0. So V is 200, current is 6.3137 multiplied by 0 gives the 0 result. So the power is equal to 0. Power factor is cos phi. It is 0. Now equation for the current and voltage. Now we know that V is equal to Vm sin omega t, whereas for current is equal to Im sin omega t minus 90. This is the equation. Now how to find the Vm? Vm is nothing but how to find the Vm? Vm, just see here, this is the RMS value. So multiplied it with the RMS value. So 200. This is Vm. Now what is Im? Im is Vm by XL. So Vm is 200 root 2 divided by XL ka value 31.42. So this is Im. So now you put these two value of Vm and Im here and write the current and voltage equation. Also you have to find omega also. Yes, omega also. So omega is equal to 2 pi f. So f is 50 hertz. So 2 pi into 50 gives 314. So now you can write here the equation. Vm is equal to 282.84, Im is equal to 9, omega is equal to 314.16 radian per second, and this is the equation of Vm and this is the equation of Im. You just write the numbers which you obtain from the calculation. In place of Im you write 9 and write the equation. In place of omega you write 314.16 and write like this. So this is the solution for circuit which has pure inductor. Now these are the some revision portion. So we, in case of L di by dt, and the equation for the voltage in case of inductor is Vm sin 2 pi ft or Vm sin omega t also. It also gives the current in the form of cos. You can present in the form of voltage also. So minus Vm by 2 pi fl cos 2 pi fl. You also write like this, minus Vm omega L cos omega t. In terms of sine, you can write like this, Vm omega L sine omega t minus pi by 2. So from here, we conclude that the current is always lag behind by the 90 degree. Okay. So, and this is the maximum value of current, Vm by omega L. This is the RMS value of current, V by omega L. For finding the maximum value, you always take maximum voltage. For finding the RMS current, take here RMS voltage divided by omega L. Now, use of complex conjugate numbers and J operator here. So when you're using J operator, you have to write like this, I is equal to minus J V by omega L. Just here you have to put J. Okay. Now here, inductive reactance is omega L. So you can write also like this, in place of omega L, you write directly XL. So if you want to remove this minus J, so put in the denominator and see V by J XL is the I current across the circuit. So this is the waveform, this is the voltage across the inductor, and this is the 90 degree lag behind current across the inductor. So this is the circuit which has the capacitor across the AC supply. Now, see, this is the condition when the AC supply is applied to a capacitor or applied to a plates across the plate of the capacitor. Then what happened? Capacitor is charged first in one direction, and after when the negative half comes, the AC supply is like this. When such type of positive waveform is coming across the capacitor, what happened? The capacitor charged in one direction, and when the supply reverse is charged in the opposite direction. So here, from here, we know that the current across capacitor is I is equal to dq by dt. Q is nothing but the charge, and we write the equation like this: Q is equal to CV. So V is here Vm sine omega t. See, so Vm sine omega t. You have to write V in place of this V. So see here, this is C multiplied by Vm sine omega t. So C Vm omega, after the differentiation we will get this. Okay, so C Vm sine omega t differentiated. So after differentiation we will get C Vm omega cos omega t. This is our equation. Okay, so this is I. Now we can rearrange these parameters. So we can write like this: Vm divided by 1 by omega c. In place of this, C Vm omega. So here you see, this is the equation: Vm divided by 1 by omega c cos omega t as it is. Now here Vm divided by 1 by omega c. Now in place of cos, we can represent in terms of sine. So you represent here sine omega t plus pi by 2 in place of cos omega t is equal to sine omega t plus pi by 2. This is the equation. So from this equation, we assume that this is the value of Im. This is what Im. So our basic equation of current is I is equal to Im sine omega t plus pi by 2. So this is the equation. Okay. So this is our equation. We also write in place of pi by 2 90 degree. Okay. So this is the main equation. Now what is this 1 by omega c? 1 by omega c is capacitive reactance. It is what? Capacitive reactance. The value and the unit of capacitive reactance is in ohm. And you know that omega is equal to 2 pi f. So 1 upon 2 pi fc is equal to xc. The capacitive reactance is represented in terms of xc, with unit is ohm. So here, from here you see that xc is having inverse relationship with the frequency. कैसा relation है? Inverse relationship. It means if frequency is increases, then capacitive reactance is decreases. If frequency is decreases, then capacitive reactance is increases. So you have xc is in the inversely proportional to 1 by f or frequency. Now the instantaneous power. The instantaneous power is instantaneous voltage multiplied by instantaneous current. So we have this equation: Vm sine omega t multiplied by Im sin omega t. So Vm sin omega t, and we write here in place of sin omega t plus 90, that is cos omega t. And now Vm Im sin multiplied by cos omega t. Again, we replace this identity with the because you know that this is the formula sin theta cos theta is equal to sin theta, and cos theta is equal to sin 2 theta. So this is the formula. So multiplication and division of 2, it will give the equation like this. So again we have a equation Vm Im divided by 2 sin 2 omega t. Here again we see that the power component is having the frequency is just double of the supply voltage and current frequency. So here you see 2 pi f, omega is what? 2 pi f. So it is 2 omega t. So it is again multiplied by 2 pi f. It means just double. So see, as per the equation of voltage and current, equation of voltage is what? Vm sin omega t, and I is equal to Im sin omega t plus 90. So here it has leading. Current is having leading phase. So see, when voltage is 0, see this is the green one is the waveform for voltage, and this red one is for the current. See, voltage is starting at 0 and follow this pattern, whereas at the time of voltage is 0, the current across the capacitor already having the peak value or the maximum value. So it has the maximum value here at voltage is equal to 0. So the waveform is starting from this. So see, this is the pattern of current across the capacitor. Clear? So this is the voltage and current waveform, and see, current is leading. Current is leading. See from the phasor diagram, current is leading here and voltage is lagging. Okay, so take the reference voltage, but current is now leading, and this is the velocity. Okay, angular velocity. Now calculation of average power, again you take the formula for the area under the curve divided by the width of the base. So 0 to 2 pi Vm Im 2 sin 2 omega t divided by 2 pi. So here Vm Im 4 pi minus cos omega t by 2, 0 to 2 pi. So when you calculate or put this limit, so what happened? Cos 4 pi and cos 0, both will give the 0 result. Okay. So average power across capacitor is also 0. Suppose here you see that this is the waveform, this is the current, this is the voltage. Now see that V and I is positive. I is positive till here and V is positive till here. So the multiplication of power is equal to V into I, give the positive power. So see, the waveform is positive. Now at this time, current is negative, but voltage is positive. Current is negative, voltage is positive, gives the negative power. So see here, this is the negative power. Now again, power is equal to here. This is the voltage and current, both are negative. So voltage and current is negative, so power is positive again. So see, power is positive, and see here, current is positive, but now voltage is negative. negative. Current is positive, but voltage is negative. Give the negative power. So in this way, the power is like this, and for this positive and negative cycle, for the pi duration, both are cancel each other. That's why the average power for the capacitor is equal to 0. So in this case again, impedance is nothing but 1 upon omega c, or this is xc. So xc is the impedance. Phase difference is 90, and cos phi is again 0 because phi is equal to 90. So what we learn from this? So we learn that xc is equal to 1 upon omega c is known as capacitive reactance, and its unit is in ohm. C is in the farad. The unit of capacitor is in farad, whereas omega is in radian per second. If you see that voltage is this, V is equal to Vm sin omega t, then current is Im sin omega t plus pi by 2. So in this pure capacitor, what happened? The voltage, the current in the capacitor leads its voltage by a 90 degree or a quarter cycle or 90 degree. Now see, this is the parameter which shows I is equal to C dV by dt, V is equal to Vm sin omega t or 2 pi ft. You also write your current equation in this fashion, 2 pi f C Vm cos 2 pi ft. You write this Im also. You also write this like this, Vm divided by 1 by C omega c. So this is also a value of Im. And you also write in terms of current Vm 1 by omega c into sine omega t plus pi by 2. So current is always leads voltage by 90 degree. Now see, this is the I. And when you're using complex number, so I is equal to having this value. Okay. Now xc is 1 upon 2 pi fc or 1 by omega c in the ohm. I is also represented as V by xc plus j. If you want to take this j in the denominator, then you have to write here negative, and you also write like this. So this is the waveform of voltage in case of capacitor, whereas this is the waveform of current in this case of capacitor, which is leading. And this is the phasor diagram, 90 degree lead. Current is 90 degree lead. Now this numerical, a capacitor has a capacitance of 30 microfarad, which is connected across 230 volt, 50 hertz supply. Find the capacitive reactance, RMS value of current, power, power factor, and equation for voltage current. Now the circuit is look like this. So we have a capacitor. The value of capacitor is 30 microfarad. Micro means 10 to the power minus 6. So you also write 30 is equal to 30 multiplied by 10 to the power minus 6 farad. So 30 C equal to 30 microfarad. Voltage is given to 30 volt with 50 hertz frequency. So xc is equal to 1 by 2 pi xc. So 1 upon 2 pi, f is 50, c 30, 10 to the power minus 6. Capacitor is given. After solving this, you will get 106.1 ohm. Now the RMS value of current. So voltage is given 230 and XC you take from the here. So 230 divided by 106.1, 2.17 ampere. The power, since the current leads from the voltage by 90 degree in pure capacitive circuit, so what is the value of power? Power is equal to VI cos phi. Now we know that in pure capacitive circuit, phi is equal to 90 degree. So it gives the 0 result. Now what is the power factor? Power factor is again cos 90 is equal to 0. Now to make the voltage and current equation. So you know that Vm sin omega t and I is equal to Im sin omega t. Here Im is what? C Vm multiplied by omega is also equal to Im. We also write in this fashion. So this is also our Im. We also write like this by Xc. Okay. So how you can find the Vm? Vm is root 2 multiplied by RMS value 230. This is the Vm. Now how you can find Im? Im is equal to root 2 multiplied by 230 divided by, what is the value of Xc here? Xc is 106.1. So this is the Im. Now what is omega? Omega is 2 pi f. So 2 pi multiplied by 50 gives you 314. So all this Vm, Im and omega you have to put in the equation. So see, the value of Vm is 325.27, whereas Im is 3.07 and the value of omega is 314. Here omega is 314. Now you put into the equation Vm sin omega t 325.27 multiplied by sin 314.16t, and I is equal to Im sin omega t plus pi by 2 equal to 3.07 sin 314.6t plus pi by 2. So this is the complete answer. So today we discussed behavior of resistance, capacitance and inductance with the AC supply. So thank you to all.